In this video we will see how to multiply two polynomials in the field GF2 powered by 8. So we already know how a polynomial looks like. So we have some constants. In our case we have an, which is the coefficient of the invariable x powered by n, and so on. And the degree of the polynomial is the power of the greatest power of the terms, as we already know. So let's see an example how to multiply two polynomials in this field. So we will have two polynomials, for example x powered by 7 plus x to the power of 5 plus x to the power of 2 plus 1 times x powered by 2 plus x, and we want to evaluate this multiplication in this field. So we will have to reduce the result modulo an irreducible polynomial. In our case we will choose to use the polynomial x powered by 8 plus x powered by 6 plus x to the power of 5 plus x to the power of 4 plus 1. So in the first case we will have to multiply these two polynomials. So we will choose this polynomial because it has a smaller number of terms. So we will multiply each term with the first polynomial. So we will have x powered by 2 times this polynomial. So as you already know, we will take each term and we will add the powers 7 plus 2. So 7 plus 2 is 9. We will have x to the power of 9 plus 5 plus 2 is 7, x to the power of 7 plus x to the power of 4 plus x to the power of 2 plus, and now we will take the second term, which is x. We will multiply with the first polynomial and we will have 7 plus 1 is x powered by 8 plus x powered by 6 plus x powered by 3 plus x. So this is the multiplication, and now we will have to reduce this using this irreducible polynomial. So in the first place we will have to see that our coefficients are in Z2. So in our case the coefficients AI, let's say, are in Z2. So we remember that the addition in Z2 is like this. If we have 1 plus 1, this will be 2 modulo 2, which is 0. 1 plus 0 is equal to 0 plus 1, and it is 1 modulo 2, and 0 plus 0 modulo 2 it is 0. So that's the multiplication for the coefficients. So if we would have here an x, for example, to the power of 5 plus I don't know which other terms, and in the end again x powered by 5, in this case we would have 2 modulo 2 times x plus 5, which is 0 times x powered by 5. So this is the way we will deal with the coefficients in Z2. In our case, we see that we do not have any x powered by a power to be repeated. So in our case, we have x powered by 9. We will write these terms in decreasing order. X powered by 9 plus x powered by 8 plus x powered by 7 plus x powered by 6 plus x powered by 4 plus x powered by 3 plus x powered by 2 plus x. And this we want to reduce it modulo this irreducible polynomial. So we will write the irreducible polynomial, which is x powered by 8 plus x powered by 6 plus x powered by 5 plus x powered by 4 plus 1. I would like to keep a place for each exponent, so that's why I will move a little bit this in order to let the place for x powered by 5, just in case we will need it. Okay, so plus nothing plus x powered by 4 plus nothing. So now what we have to do is to extract 8 from 9. 9 minus 8 is 1. So we will have to multiply this polynomial by x. So x powered by 1 times x powered by 8 is 8 plus 1 is 9. So we will have x powered by 9. So I will repeat again. We will look to the greatest power. In our case is 9 and 8. We will compute 9 minus 8. That's 1. And we will have here x powered by 1. And we will multiply this polynomial by x. So we will add 1 to each power plus x powered by 7 plus x powered by 6 plus x powered by 5 plus x. So now we will add the coefficients. 1 plus 1 modulo 2 is 0. So here we will have 0, which means nothing. We will have x powered by 8 plus 1 plus 1 is 0, so we will have nothing here. Okay, nothing here, nothing here, plus x powered by 5 plus x powered by 4 plus x powered by 3 plus x powered by 2. This will reduce. 1 plus 1 is 0, and this is 0. So now we will have to reduce it again, because what we need is a polynomial with the degree at most 7. So that's what we need, because in the field GF of 2 powered by 8 we will have polynomials of degree maximum being 7. So we will write here a plus, and we will multiply by 1, because we will have 8 minus 8, which is 0, and we will have x powered by 0, which is 1. So we will write here 1, which is x powered by 0. So we will multiply 1 by this polynomial. So we will have x powered by 8 plus x powered by 6 plus x powered by 5 plus x powered by 4 plus 1. So that's all what we have. So here will be nothing, x powered by 6, 1 plus 1 is 0, 1 plus 1 is 0, so nothing, plus x powered by 3 plus x powered by 2 plus 1. And that's the remainder when we reduced this polynomial by this irreducible polynomial. So our result is x powered by 6 plus x powered by 3 plus x powered by 2 plus 1. And that's all. So in this field we will have a degree at most 7, and all the polynomials are in, all the coefficients are in Z2. So that's what we have to keep in mind, Okay, that's a way of how can we multiply these two polynomials and reduce the result modulo an irreducible polynomial. Okay, in the next video we will see another method to multiply these two polynomials. So you can subscribe, you have the button here. And thanks for watching, and I hope that will help you. Goodbye.